In this video, we're going to take a look at solving a couple of equations that involve parentheses. And the first thing I like to try to do in equations like these is to see if there's anything that can be done to simplify what's inside the parentheses. In other words, can I combine any terms inside the parentheses before I go any further? And in this case, we cannot. So we're going to start right off with the distributive property. So if we have a number or a symbol out in front of a parentheses, the distributive property tells us to multiply that number in front times each of the terms inside the parentheses. And so the first step would be 7 times x plus 7 times 2 equals, and then we do the same thing on the right hand side. 2 times 2x plus 2 times 9. And so we can do a little bit of simplifying here. So 7 times x we can write as 7x plus 7 times 2 is 14, and 2 times 2x is 4x, and plus 2 times 9 is 18. Okay, so now our next step will be to try to get all of our x's on one side of the equation and all of our numbers on the other side. And so in order to do that, I'm going to subtract 4x from the right-hand side. If I do that, I need to subtract 4x on the left-hand side. You might ask, well, why would I do that? I want to undo the 4x over here on the right to bring it over on the left. That means if I have a plus 4x, I need a minus 4x to cancel that out. But if I do that on the right, I have to do it on the left to keep this equation balanced. Okay, so the 4x's cancel over here on the right-hand side. And on the left-hand side, 7x minus 4x is equal to 3x. And now I can just bring everything else down. So I have 7 minus 4x is 3x. I bring down the 14x and I brought down the 18. Alright, so we're a lot closer to our solution. We've isolated 3x on the left-hand side. All of our x's on one side. Now we need to get all of our numbers on the right-hand side. So we have a plus 14, 3x plus 14. We want to separate the 14 from 3x and get it to the right-hand side. So to undo the addition, we're going to do subtraction. But if I do that on the left-hand side, the subtraction of 14 on the left, I have to subtract 14 on the right. And so 14 minus 14 becomes 0. So on the left-hand side, I have 3x plus 0, or simply 3x. On the right-hand side, I have 18 minus 14, which is 4. So now I have 3 times x equals 4. Right, so let's go to the right a little bit. So I want to make an example down below. So if I have 3 times x equals 4, then what I want to do is isolate the x all by itself. Remember, we're solving for x. So I need to undo the operation of multiplying by 3, which means I'm going to divide. Let me rewrite it over here. I'm going to divide by 3 to help cancel out the multiplying by 3. So if I divide by 3 on the left-hand side, you'll notice the 3's will eventually cancel. But if I divide by 3 on the left, I must also divide by 3 on the right-hand side. 3's cancel out, I end up with x equaling 4/3. Okay, so that's our answer for x in this original equation. I won't go back. It's a very good exercise to check that your answer actually works. I'll get you started on the check and then leave the rest for you as an exercise. So what we want to do is we want to check whether or not 4/3 makes this equation equal or balanced. So that means if we have 7, and instead of x, I'm going to write 4/3. Let me put that in blue to remind you that that's the answer we ended up with. 4/3 plus 2 is that in fact equal to 2 parentheses 2 times 4/3 plus 9. Okay, so now what we need to do is we need to add 4/3 plus 2. And to do that, one way would be to rewrite 2 in terms of the denominator for 3, which would be 6/3. 2 is equal to 6/3. And you can convince yourself of that if you like. You can pause the video and try that. Convince yourself. So we have 4/3 plus 6/3. That is 10/3. And again, I'm going a little bit quickly through the check. You can go back if you like, and move a little slower, or use a calculator if you feel more comfortable just to check this answer. And then on the right-hand side, we want to see, is that equal to what we have on the left? On the right, we have 2 times 4/3. We can make that 2 over 1 if you like. 2 times 4 is 8 over 1 times 3 is 3. And then we add 9. And so the next step we would want to do is to convert the 9 into a fraction where 3 is the denominator. Again, I'm going to cut to the chase. That's 27/3. So now we want to check whether or not 7 times 10/3 is that equal to 2 times 8/3 plus 27/3. So we have 7 times 10 is 70/3. Is that equal to 2 times 8/3 plus 27/3 gives us 35/3. So 2 times 35 is 70/3. So yes, this does check out. If you want to use a calculator, if you want to go back over this again yourself, that would be a great exercise. But this gives you a quick check on the fact that our answer does make sense. It works in the original solution, or the original equation. Okay, let's try one more example where we have an equation that involves some fractions. It's a little bit more involved. So let's solve the equation. Change that to green. So we want to solve the equation x over 5 plus x minus 3 all over 2, and that's equal to 7. We want to solve for x. Okay, in this case, we want to find the common denominator. Because we have two fractions with different denominators, we need to find a common denominator. So you might notice that the least common multiple, or the least common denominator, between 5 and 2 is equal to 10. That's going to be an important piece of information to hold on to. So we're going to rewrite this entire expression, simplifying it a bit. So let's start over here. We have x over 5 plus x minus 3 over 2 equals 7. Okay, so now in order to get rid of these fractions, we want to multiply each term of the equation by this least common denominator. That will help clean out our fractions. So if we multiply everything, each term, by 10, which is our least common denominator, I'll change the color here actually. I'll draw a little extra attention to it. So we want to multiply each term by the least common denominator on both sides of the equation. That keeps it in balance. We haven't changed the balance of this equation. We've just built it up by a factor of 10, and that factor of 10 was chosen because it was the least common denominator. It'll help us clear out these denominators here. So now 10 cancels with 5 a bit. We're left with a factor of 2. And here the 10 cancels with the 2 and leaves us with a factor of 5. And so what we're left with here is 2 times x, which is 2x, plus 5. Now I'm going to put parentheses around the x minus 3 because that 5 wants to be multiplied by the entire numerator, x minus 3. And that's equal to 7 times 10, or 70. And so now we have a very similar kind of problem that we had above, where we are solving an equation that involves parentheses. So the first thing we wanted to do in that case was look to see if there's anything that can be simplified inside the parentheses. There is not. So now we're going to distribute the 5 through each term in the parentheses. And so we're left with 5x minus 15. And so now we just bring down the 2x. And that's equal to 70. Okay, now we want to see if there's anything we can do to combine terms. Well, here we have a 2x and a 5x. Those can be combined. 2x plus 5x is equal to 7x minus 15 equals 70. Okay, so now we want to add 15 to both sides in order to help cancel out the subtraction of 15. So let's add 15 to both sides, plus 15 to keep this equation balanced. Okay, so those cancel, minus 15 and 15 cancel. So I'm left with 7x equals 70 plus 15 is 85. Okay, so let's go up here just a bit. And so now we have 7x equals 85, or 7 times x equals 85. And in order to get x all by itself, isolate or solve for x, we want to undo the multiplication between the 7 and the x, so we divide both sides by 7, which gives us x equaling 85 sevenths. If you want to write that as a mixed fraction, that is 12 and 1/7. I like the improper fraction. You can go back and check that by substituting 85 sevenths into the original equation. I'll leave that as an exercise.